So what we talked about last time were queues and stacks. And yeah, we could go ahead and use queues and stacks in some sample code, but they are so much like array lists that I'm going to skip them. Right. You would know how to create a queue or a stack if you needed to. You just do something like this. I could even do it in Java. I mean, I guess it wouldn't hurt. Why not? Let's do it in Java. Let's see which classes they recommend for our queues and for our stacks. They have a queue class, so we'll give that one a shot. And there should be a stack class, which they are implementing using array deck. I'm going to skip that. Let's just do the queue. So we're on lecture M, I believe. Get rid of the package declaration, but please create the main class. I made that mistake last time. All right, so here I'm just going to create a queue. So queue, make it a queue of strings. Queue equals new queue, diamonds, parentheses. It will indeed complain that it doesn't know what that is, so I'm going to add an import for java.util.queue. And as soon as I do that, I'm going to come up here and change that to java.util.asterisk so I don't have to keep adding imports. You still doesn't like it. Why don't you like it? Implement all abstract methods. Queue is abstract, cannot be instantiated. Alrighty, so that was the wrong choice to do. Which Java queue class to use? Queue is an interface, and we've already discussed what an interface is. So there should be classes that implement the queue interface. So I'm going to click on queue implementations, and we will see that there's one called a priority queue. Priority queue is a priority queue based on the heap data structure. Okay. And linked list. Let's just go with linked list to implement the queue. We don't need a priority queue, which allows us to insert a priority level so that the highest priority people wind up being on top. I mean, that'd be pretty neat, but let's do that. So we're going to do linked list string is equal to new linked list. Now we need to figure out how to add and remove items from it. So queue dot add. That looks pretty easy. And then there's remove first. And then there's toArray, sublist, pop. Push and pop. Push and pop will make it act like it's a stack. Apparently, the linked list class can be used for both stacks and queues. All right, well, let's treat it like a stack then. Queue.push 1, queue.push parentheses 2 in parentheses, queue.push 3, not there, 3, and let's get those values out. String s is equal to queue.pop parentheses in parentheses. Let's just make that string s1. And string s2 equals queue.pop, parentheses in parentheses. So what's left on our stack? Let's find out. 4 parentheses string v colon q. Funny that we're treating it like a stack. Oh well. we could go and we could refactor this so that Q was the word stack. It'd look a little bit better. But anyways, let's just do this. System.out.println parentheses Q. No. Let's print out that element that we just have left over, right? V. So let's put left in stack colon V, or left in stack colon end quote plus V, just to print out every element that's in the stack. And I love this change. Use functional operation, and it changes it to that. Now if you can get that to work, you're way awesome. I mean, of course you can get it to work, you can just click that, but if you can understand it, we're not talking about functional programming. I'm going to undo that, now I'm going to run it. All right, and so what was left in the stack? The 1, right? Because we pushed 1, 2, 3, and then if we printed them out, S1 is going to equal 3, S2 is going to equal 2. It's a little bit confusing, but let's just roll with it. You understand. It's last in, first out. It's first in, last out. These things were popped out, so this equaled 3, this equaled 2, and what was left was 1. Now let's clear our Q. So C.clear, parentheses in parentheses. So blocking Q might work. Blocking Q extends Q with operations that wait for the Q to become non-empty. Let's play with blocking Q, just because I want to see methods that look exactly like what we would see in a queue. So blocking with a capital B, Q with a capital Q, BQ equals new. Whoops, what did I forget? I forgot to specify what kind of data I'm storing in it. How about just numbers this time? So double with a capital D. BQ equals new. Blocking Q, capital B, capital Q, empty angles, empty parentheses. Add import for java.util.concurrent.blockingQ. So adding java.util.star wasn't enough. It wants to pull something out of the java.util.concurrent package. What does concurrent mean? I mentioned that the last time. If you're creating a multi-threaded application where you have more than one thread of execution inside your application trying to access the main memory, then memory can get corrupted unless you use data structures that are designed to handle that. And this is one of them. So why not? Add that import. Now what? Blocking Q. Oh, come on. Is abstract and cannot be instantiated. Well, what can be? I don't have my PowerPoint uploaded about which sample queue that I've done in the past. I should have just stuck with my gut and gone straight to hash maps. I don't want to create a new queue. I just want to create blocking queue implementations. Array blocking queue, delay queue, linked blocking queue, priority blocking queue. Let's look at what a linked blocking queue is. It's a class that implements a blocking queue interface. Sounds great. Let's do it. So change this word to the linked blocking queue. Add an import for that. Alrighty. Finally, BQ dot there's peak. What does peak do? It looks at the top element without removing it. So we can add things to it. BQ.add, and via boxing, we don't need to create a double object to pass in there. That'll happen automatically. So BQ.add 5.66, BQ.add 6.77, whatever, you know. And then BQ.add 8.99. So how do we get our data out of it? In the same order that we had just pulled them in from, or that we just added. Well, there's the constructor, but we don't care about the constructor. We just want to know a cute example for stepping through them. Here we go, adding some numbers. Print the queue. Well, I don't want to print the queue with a single print statement. I want to be pulling the data out. That doesn't show how to pull the data out. I know, I can just call .remove. I like this one, drain. Remove all available elements from this queue and add them to the given collection. Drain to another collection. Offer inserts the specified element at the tail of this queue. Peek retrieves but does not return the head of the queue. And then poll retrieves and removes the head of the queue. So let's do that. We will poll our data out. While parentheses BQ dot size parentheses in parentheses greater than 0, while there are pieces of data in it, let's get our number. Double D is equal to BQ dot poll. And what does poll do? Poll grabs and removes the first element, whereas add is adding items onto the end. And so that's what's making this a queue. We're adding items onto the end, but we're pulling them out from the beginning. Just like people standing in a movie line. New people come up, they stand in line at the end, but the people who are getting the tickets and walking into the theater are the ones at the beginning. And so let's print out what we just popped. Not popped. Polled. System.out.println parentheses quote Q polled equals end quote plus D parentheses semicolon. And we'll see them pop in the same order. Not pop, poll. We will see them poll in the same order that they had been added. And there they go. 5, 6, and 8, the same order. Is it a problem that we have that type here and that type here? No, this is an interface specification, but you can use an interface specification as your reference type as long as the object that it's pointing to is a class that implements that interface. But honestly, I would probably be happier with myself if I change that blocking queue equal to that. All right, and so a computer science textbook would probably call this an enqueue feature, enqueue function. And a computer science textbook would probably call this the dequeue function. All right, if this is working for y'all, then what we want to do is we want to go ahead and do the sorted map example. What is a map? It's called a dictionary in some languages. It's a mapping between keys and values. So let's make our sorted map, and it's going to map first names to colors. We want to know these kids and their favorite colors. So sorted map string comma string in parentheses or end angle SM for map, sorted map equals new sorted map, capital S, capital M, angles, parentheses, semicolon. You gotta be kidding me. All right, so what is an example of a sorted map class? TreeMap. All right, so we'll go with TreeMap. Change sorted map to TreeMap. And instead of SM, I'm going to make it TM. All right, let's add some elements. Now, if you've taken Python, this is how you would have done it in Python. Don't type this because it's not how you do it in this language. TM Fred is equal to his favorite color is blue, right? Like that. Not quite as easy because this language does not allow operator overloading where you can treat things like they are arrays even though they are not. But we can do this, tm.add. TM dot, let's look at the list of methods. There's a remove method. There should be a get method. And then there needs to be an add method. Why am I not seeing anything that looks like an add? Contains key, that's terribly important. All of these things are very important, but how could you get data without having added data? Put, there we go, put. Okay, so I'm going to put Fred's favorite color as blue. And let's add some more colors. tm.put Sally's favorite color is green. And tm.put Joe's favorite color is red. Like that. Now, since this is a sorted map, if we just use a for loop to step through it, it'll print them out by order of key. Or we can retrieve an element by its key and get its value. So for example, say that we want to know what color Fred likes. String color is equal to, but we could check to see if Fred is even in there. So let's create a string called name because this is the person that we're curious about. String name is equal to Fred. If tm dot contains key parentheses name, that means that Fred is in there. And we can do something cool. We could remove it from the list. We can get the data. String color equals tm dot get based on the key. And in this case, the key is the name. And I was expecting it to crash and tell me that it did not know what type was being returned here, because what is being returned here is a generic object. It seems to know, and I really doubt that this is true, that just because that is a string, it's returning a string there. We're going to have to play with that and insert some doubles into a map and see if it works the same way. But for now, we can find out. Let's print out system.out.printf, parentheses quote, and let's print out the name and the color. %s loves the color %s \n, end quote, comma, name, comma, color, end parentheses, semicolon. And we should put an else here saying that that name does not exist, right? But Fred doesn't indeed love the color blue. Very true. Why did I close that? Let's make a different tree map. Tree map, and let's do names and numbers, so it could be called scores. So string for the names, those are the keys, and double, those are the scores. After the angle, scores is equal to new tree map, open parentheses, close parentheses. Whoops, I forgot my less than greater than before the parentheses. So tm.put Fred earned a 90. So quote Fred, end quote, earned a 90. In parentheses, semicolon, tm.put quote Bob earned a 95. And it's not put there. No suitable method found. Ints cannot be converted to... Does it want these to be doubles? Is it refusing to box them because they are not doubles? You're really going to make me box it myself? New double parentheses 90.0? Scores dot. Okay, thank you. TM is the name of our prior list. Heh. Okay. Scores dot put and scores dot put. And since the boxing happens automatically, you don't need to do that new double business. That's what's happening behind the scenes. But we don't need to. The Java virtual machine adds that code to us. Gives us that code when it needs it. All right, good, it compiles. Thank you for noticing that. I was getting quite irate. And let's pull out Bob's score. But let's try pulling it out without having checked to see if the key is contained there first, right? So we could use lowercase d. Double score, score equals scores dot get parentheses quote Fred, end quote, in parentheses semicolon. And we can print that out. System.out.printf. System.out.printf, parentheses quote, %s scored %f for floating point. How about making it %.2f? Just to make it look cute. %.2f. After the f, let's put a \n. After the comma, let's put the values that we're filling into the placeholders. I never did store Fred in a name. That's lame. So I'm just going to hard code Fred in there. That is terribly lame. And then the score that he got. Now this should work. It's not going to crash because Fred is indeed in there. He scored a 90. But what happens if we look for Freddie? Whoops, I'm going to change this one back to Fred. But the other two, I've changed to Freddie. Oh, it's really irritating me that I've done it like this. Sorry. Name is equal to Freddie. Let's do it like we should have done to begin with. And let's get out the variable stored, the value stored in the name variable. And let's replace Freddie down here with name as well. Okay. And it blows up with a null pointer exception. The method returned null. So strictly speaking, you don't have to use .contains to check to see if that key exists. You could check the return value, but no, that's not necessarily true. I bet even if I'm not doing anything with the result, I don't have to make these changes. I'm going to try to fix them pretty soon so that we're actually using contains. I'm just exploring what kind of errors we get from it. Okay, so that's interesting. We would have to store, to make this code ironclad, it in a capital D double. And then when we stored it into here, we would have to check the result to see if it was null. And that's all a bit too much. So instead we're going to check to see if it exists in the map, just like we did the other time. If scores dot contains key parentheses name in parentheses curly brace, we're going to do those two things. Else, this time let's go ahead and print an error message because it's true that it's not in there. else system.out.printf parentheses quote %s has no score in the map. Not that a user wants to see what the word map there is. End quote, comma, name. Right. Or we could just say, not found. User would rather see that. But right, Freddie has no score. How about we delete in the map? There we go. What if we wanted to print them all out? We just want to see a dump of the entire map. Well, we can always just try system.out.println parentheses scores. Java will do its best to call a toString method and generate something. Let's see if it generates anything that's usable. Yeah, see? It looks like a little list. It's got the key value pairs in it. But let's write our own loop to do it. So the keys are strings, the values are doubles, so for parentheses string s colon scores for every string, let's call that key, for every string in the key, for every key in the scores, and it's complaining about this. Interesting. It's not iterable. Well, okay. If it's not iterable, then let's back off from that. Iterate through. What kind of map are we playing with right now? We are playing with a TreeMap, I believe. So iterate through TreeMap Java with a for loop. I'd rather the simplest one rather than something complicated. That's looking complicated. Well, okay, that one is too. Fine. I guess I am misremembering how to do this from C# where it's easy. So here's what they're doing, is they're creating a set of keys, and they're pulling the keys out and the values out. So we should be able to get a list of keys from it. And we're not going to play with this for too long if it doesn't look like it's going to be easy. But if we type in scores dot, can we get a list or an array of keys? Values. Don't want that. Floor key for each. I'm going to punt on this one for now. I don't feel like... what did I have here? Key set. But I didn't see that when I was typing this in. Scores dot A, B, C, D, E, F, G, H, I. Oh, it is right there. Okay. Well, let's do that. It'll return a set of the keys contained in this map. So we're going to need a set in order to get that to work. We haven't used a set, but a set is just like an array list except that it has no order. The order is not guaranteed at all. But we can still step through it in whatever order that it gave it to us. I'll be curious to see. No, I'm really irked. I don't want to mess with it that way, so I'm just going to punt on that idea. So, although it's really nagging at me, let's see if I can resist the urge. So that's the TreeMap class. The TreeMap implements the sorted map, whereas a hash map is not sorted. Meaning that if we iterated through it, which is really what I was trying to do, then they would not necessarily be in order. So let's Google up the difference between the tree map and the hash map so that You'll believe me that there is a difference. TreeMap versus HashMap. HashMap is implemented as a hash table and there's no ordering. TreeMap is implemented based on a red-black tree structure, which if you ever go and take a 4-year computer science course, you're going to have to learn about. A tree structure is a way of organizing data so that it can be iterated through very quickly and is ordered by the key. Is TreeMap synchronized? TreeMap is not synchronized. If the map is accessed by multiple threads, then the data must be synchronized externally. We can learn how to do that, we will, but we're not going to do that right now. I'm going to take one more stab at it. For loop, TreeMap. Well, that looks okay. Map.entry for every map.entry. String, comma, string. Entry, colon, and the no, I'm still going to bail out on that. I need to go back to my examples and see why I thought it was easier to step through that than it seems to be. Okay, so to put a value into the map, it's put. To get a value from it, it's get. If you want to remove it, you can call .remove. Say that we don't want Fred to have a score anymore. We can do that. So scores.remove parentheses quote Fred end quote in parentheses semicolon, right? That'll remove his Fred's score from the list, from the, not a list, from the map, which we could prove by just printing it out again. System.out.println parentheses scores in parentheses semicolon. There. Fred has been removed from the list. It would generate an exception if we tried to remove Fred and Fred was not in the map. So you would not want to necessarily do that. All right, so let's do one more, which just maps integers to integers. So TreeMap less than the whole word integer with a capital I, integer, comma, integer. Just going to call it map, for lack of a more clever name, equals new TreeMap less than, greater than, parentheses, in parentheses. Now let's put some data values in there. And I don't want to put them in any particular order because I don't want it to, when I step through them, I'm curious if they're going to come out in the same order that we have inserted them in or if they're going to be organized by their ascending value of the key. So I think like putting 4 values in there, just make sure that they're not either all in this reverse order or in straightforward order. And now let's get the list of keys as a set. So a set, angle, integer, close angle, greater than, keys, equals, map dot key set, parentheses in parentheses semicolon. And we can step through those keys and get the values. So for parentheses, every integer in that set, so for integer with a capital I, key, let's just call it I, colon keys, close parentheses. Let's get the result, int, or the value for that key. I almost want to make that the word key. I think I will. Normally I hate to put things where they're different only by a plural or a singular, but I'm going to roll with it. So int value, I'm pretty sure that these keys do exist in the map because we just got them out, so I'm not going to add the contains key code around it. So is equal to map.get parentheses based on the key in parentheses, and let's print them out. System.out.println parentheses key plus a quote space quote plus the value. Can use functional operators. All right, undo that. Let's see what order they come out. Do they come in the order that they're added? Do they go in an ascending order? Even though a set supposedly has no order, maybe it's going to work that way. Or is it just completely random? Let's find out. 1, 3, 6, 10. The order is preserved, which is interesting to me because a set has no specific order. That's the entire point of a set. But I guess inside it has to have some particular order, right? Otherwise you wouldn't be able to iterate through it at all. And in this particular case, if you call key set, it returns it to you. All right, I will not forget that now. That is how you pull out a list, not a list, a set of all the keys so that you can then iterate through it. Iterate through your tree map. Iterate through your map by getting a set of keys and then use a for each loop to step through those keys, getting the value for that key from the map. Now that is what we're doing there.
Was it the order when it's ascending?
Yeah, so the set is an ascending value. Let's prove that to ourselves. Let's insert these all in descending order, right? I still wanted to see, I want to watch it come out 10, 100, 300, 600. And there we go, 10, 100, 300, 600. So it maintains its order. Very cool. How have I done that in the past without using a set? I do not recall. Well, too bad. We'll go from there. So, I'm pretty happy with the demonstration that we've done so far. We did a demonstration of a queue as a linked list, and just so that we can tell that it is a queue, no, wait, this was a stack. We did push and pop on it. So I'm going to highlight that queue and do refactor rename and call it lowercase stack. Now, since it's a linked list, you can access it in other ways other than a stack. You could call .add, right, and you could use .get to get a value from the middle of it. So you could violate its tenant, but you can treat it like it's a stack. And if we used the word stack here, I bet then we would be limited. Nope, forget it. Never mind that. Back out. All right. So I'm going to add a comma to here. We can use a linked list as a stack by restricting ourselves to the push, pop, and peek functions. Peek just looks at the top element without destroying it, whereas pop actually does destroy it once it returns. So by limiting our method calls to peek, push, and pop. And BQ is too boring of a name, so I'm going to do the same thing for that one. I'm going to refactor BQ. It's making me hungry thinking about Burger Queen. No, that's stupid. Rename that just to Q. use linked blocking queue as our queue. There are many, many, many kinds of structures that can be used as a queue. Let's see if we can go find a hierarchy chart that looks like this one, but for queues. Oh, they used array deck as their queue. What would happen if I replaced our blocking queue with array deck? Would that work just as well? Array deq eu is equal to new array deq eu. Yes, that still compiles, and I would roll with that, because if you're not writing concurrent software where you have multiple threads of execution in the same application, then doing that locking and unlocking of memory just slows it down. So let's go ahead and make some notes down here at the bottom. TreeMap maintains a sorted order by key. HashMap does not. It's the only difference. Makes me think that maybe HashMap is a little bit faster. Otherwise, why would you care to create one? We can use linked list to implement a stack. We can use my brain's already slipped. What did we use for our queue? Array deq eu. Array deq eu to implement a queue. For stack, we use push and pop. For the queue, I wish that they were called NQ and DQ like a computer science book would tell us, but instead they use, just to remind myself, add. Oh, we never removed anything from it. And poll. Add, poll, and peek. For maps, use add and get. Use contains key to see if the key exists in the map. Use key set to return a set of keys to iterate through. Step through with a loop. Check something. So what are we going to do with our map? Well, do you remember our our assignment where we created a whole bunch of random numbers and then we set them into an array, the two-dimensional array, using the random numbers as our x and y values? One thing that's important to know about a map is that if you add a value again, if it has the same key, then the new value replaces the old one. So for example, if I do this, map.put 100, 1000, that old value is now gone. These keys are unique. You cannot put more than one key in. I mean, you can, but each time you do it, you're overriding the value. Just like in a dictionary, pretend that each dictionary could only have one definition per word. And so when you were putting, the definition for the word bear in it, then you'd erase the old definition and scribble in your new one. That's kind of stupid maybe, but let's add a comment to that effect. The keys are unique if you use put with a key that already exists. It replaces the value that is associated with that key. So our homework is going to be kind of like that other one, except we're not going to fill in the values of the array, the two-dimensional array, with it. Come on. Still not used to this keyboard on the machine here. All right, so homework. Create a tree map that uses integer for the key and integer for the value. Create 100 random number pairs using the first number as the key and the second number as the value. Putting each pair into the map, and then print the map with a for loop as shown in the notes for lecture M with the key set. Now that actually makes it almost too easy, because our key set example was also with integer pairs, right? But anyways, so if you happen to generate a number for 1,6 and then you generate a number for 1,7, it's going to replace that 1,6 value with 1,7. So if you were going to use these as rows and columns, it would mean that there would only be one random value for each row, which would be kind of interesting to see. But let's not mess with that for right now. Maybe we'll have a later homework assignment where we go back and do a two-dimensional map with it, with that idea. We could spend a week, 2 weeks on just implementing things with maps. One thing we haven't done is use our own data class to create a data class that we're inserting into the tree map. We're just about out of time, so I don't think we're going to have time to do that. But for example, I'm going to do something silly and declare a class right here and now. And I'm going to call it just, I don't know, PT for point. And it's got two values, int x and y, right? Well, you can make a map of strings that match to points, right? So tree map less than string, and then PT, I guess I'll just call it PT map, equals new tree map less than, greater than, parentheses, in parentheses, semicolon, like that. And then we could create new points and add them to our map, right? So PT, I think I'll just call it temp, equals new PT, parentheses, in parentheses, pt.x equals 3, pt.y equals 4, excuse me, that was supposed to be tmp, tmp.x equals 3, tmpy is equal to 4, and then add that to our tree map along with somebody's name. Fred's getting a point. Good for him. pt map dot put parentheses quote Fred end quote comma temp, like that. And now we have added, this is our key, this is what we would retrieve it by, and the value is actually a structure, a class, an object of our own type, rather than relying upon the wrapper classes that we've been using, the string and the double with a capital D and the integer with a capital I. So we could get that point back out if we so chose, but we would have to cast its result. PT new point equals parentheses PT, because we got to cast the results back as a point. And the first thing I'm going to do when I'm done typing is delete that and see if that statement is still true. ptmap.get based on quote thread, end quote, in parentheses, semicolon. Well, it's compiling. What happens if I take this out? Wow, they've gotten more generous in fascinating. To prove that it worked, let's print out x and y. System.out.printf, parentheses, quote, x equals %d, y equals %d \n. End quote, comma, new pt.x, comma, new pt.y, in parentheses, semicolon. And it worked. Okay. They have done some changes in the most recent version of Java, unless my memory is totally shot. Used to be that if you were getting a piece of data out like that from it, you would have to cast it into the type of it because it was just returning an object. If we call ptmap.get, oh, it's so smart it knows it's returning a point. That's wild. Okay. Cool. That's via the magic of templates. This is a template right here. And apparently when you say that this value is a point, it knows enough to say that that's what you're returning. Okay. So anyways, we could do another example on TreeMaps that does something like that and does something a little bit more useful. But not today. Let's go ahead and stop here. And I didn't check. How are y'all doing on the typing and the syntax